Okay, here's what we had yesterday, right? We looked at an example where we were supposed to factor this completely, right? Supposed to factor this polynomial completely. We warmed up with this example, right? If we have x squared plus 15x minus 16, we're supposed to factor that. We're just finding magic numbers, and we found it. Positive 16 and negative 1, and we're done. But what if instead we have a problem like this where it's not x squared and x, it's x to the fourth and x squared, right? The trick is to think about this in terms of packets of something so it looks like the first problem. So it looks like I've got a quadratic expression where a is 1, b is 15, and c is negative 16, right? But in order for it to be quadratic, it's got to be like ax squared plus bx plus c. Or a, it doesn't have to be x, right? It could be something else, but a times something squared plus b times something plus c. Well, the something to make that happen is an x squared. That's the whole point, right? Is we can split this up into packets of x squared so it still looks quadratic, okay? And we can still factor it the same way. We're just trying to find magic numbers because a is equal to 1 and c equals negative 16 and b is 15. The magic numbers are the same, positive 16 and negative 1. But when we break this into factored form, instead of this being x plus 16 and x minus 1, it's x squared plus 16 and x squared minus 1, right? And you can see if I were to multiply this out, when I distribute the x squared, well, what's x squared times x squared? X to the fourth, right? There's my x to the fourth. And if I distribute here, I'd get a minus 1x squared and a plus 16x squared adds up to a 15x squared. And then 16 times negative 1 is my negative 16, right? So that's the trick. We're still using magic numbers. We just have to package this so it looks like it's a quadratic expression, right? Now, what if the question asked me to solve something instead? Okay, so if we were supposed to solve, let's say this whole thing equaled 0, right? Instead of what we did here. So if I take the same problem, let's say this time it's just going to be solve x to the fourth plus 15x squared minus 16 equals 0, got it in standard form, right, already, then I would do the very same process, right? I would do all the same stuff I did, and I would end up getting it down. Oh, by the way, we didn't quite finish factoring it, though, did we? I got to go back for just a moment. So we got it broken down into x squared plus 16 times x squared minus 1, just like we got in this last example, right? We factored it. But this time we could go a little bit further, couldn't I? Right? I could go a little bit further because I've got both of these are quadratic. Now the pattern that this one would fit is a sum of squares, which doesn't exist. So I can't factor that one any further, right? There's no pattern that allows me to proceed any further. But this one right here, x squared minus 1, I could write as x squared minus 1 squared. And so it's fitting the pattern a squared minus b squared. That is a factoring pattern, right? That's the one that breaks into a plus b times a minus b, right? And so my a is x squared and my b is 1, right? And so it factors into x, or my a is x. I get a squared minus b squared. So I end up with x plus 1 times x minus 1, okay? So that would be completely factored right there, right? Okay? Well, what if we're solving this, it's just an equation, right? If we're just solving this equation. We already did all the hard work. We can think of this as being something squared, 1 times something squared plus 15 times something minus 16 if my something is an x squared. Just like before, we can factor it just like before. The magic numbers this is going to break into are plus 16 and minus 1, only this time I'm getting x squareds there, right? Now the whole thing equals 0, okay? Do I need to factor it anymore? No. Now I can just apply the zero product property and set those factors equal to 0 and solve, right? I don't really need to do that extra step where I break this apart using a difference of squares. Isn't it just as easy, or maybe even easier, just to set those equal to 0 and solve, right? Like this one right here, if I just set that equal to 0, set that factor equal to 0 and solve, what are the two steps to solve for x? It's easy. Add 1 and square root, right? So I get x squared equals 1, so x equals plus or minus 1. There's my two zeros, right? Okay, for this other guy over here, I would have to set this one, I would just set it equal to 0 and solve. Pretty easy. What do? Subtract 16. Square root it, right? And so I get x equals what? Plus or minus? I, good, because I'm square rooting a negative. Good, I've got that negative there, which gives me an I, okay? And so I get my four complex zeros. Two of them are real and two of them are imaginary, right? Make sense? Okay, go.